Let's move on next presentation. Lorian Platt. At previous presentation, Kaneko already introduced Lorian, so let me introduce her again. She is founder and chief scientist from Conteria Inc. Lorian is computer scientist in two fields, transfer learning and decision intelligence. Since 1988, she has been a thought leader in research on the use of machine learning as an academic, professor, industry analyst, and practicing data scientist. In this talk, she will give a presentation at her latest book showing the methodology for decision intelligence. Lorian, please give a presentation.
Turn on your sound.
Ohio, Nihon. Domo arigatou gozaimasu. Hello. That is all the Japanese that I can speak, not much. But thank you so much for that great introduction, Kaneko-san, and the overview of decision intelligence. Today, I will take what you introduced to the next level. I truly believe that decision intelligence is the most important technology building on data and building on artificial intelligence in the 21st century, valuable not just for businesses, but also for solving some of the hardest problems that we face as a society and for climate as well. So by way of quick background, as you introduced, I won't repeat this, I have a decision intelligence book called Link that was published in 2019. And then I have a new book called the Decision Intelligence Handbook that you can see here that will be released in early release in the next few weeks and available in full publication in early 2023. And I have a dog. So today, I will begin by telling you a little bit more background about decision intelligence. I'll go very fast because Kaneko-san gave quite a good background, I think, although I couldn't understand the Japanese. I think it was a good overview of decision intelligence. We'll go into some details defining decision intelligence and talking about how it's different than some of the other decision disciplines like machine learning and the DMN, the decision modeling notation. Then we will talk in more detail about a specific technology diagramming approach called a causal decision diagram, and then talk a little more about its connection technology and finish by talking about how decision intelligence can solve some of the hardest problems that we face, both in business as well as for society at large. So very quickly, I think you've already seen this. Gartner predicts that 1/3 of all large organizations will use decision intelligence by next year. You saw the prediction we heard earlier of a $36 billion market for decision intelligence by 2030. And really, decision intelligence's purpose is to bridge the gap between what's going on with AI, business intelligence, decision support, a number of different technologies, and human decision makers, again, whether they're in commercial organizations or in government, or just individuals trying to make decisions in complex environments. We already saw that decision intelligence is featured by the Gartner Group. It's on 2 hype cycles, being tracked as an important and growing technology within the AI realm, but also for data and analytics in general. Decision intelligence news is exploding. There are new vendors in decision intelligence I hear about every week, and you can track these at decisionintelligencenews.com, which is a website you can visit now. But what really is decision intelligence? What defines this exciting and important new field? If we look back to the last 20 or 30 years, data has become much less expensive to manage, has become much more voluminous. Data is bigger than it's ever been. In the last couple of decades, we've built on data to create machine learning and artificial intelligence models that use that data to go beyond information and to provide insights. These technologies, though, stop short of answering a very important question, which is, what should I do? What action should I take to achieve some particular outcome? And we'll talk about actions and outcomes throughout this presentation, because this is what makes decision intelligence different. People think in terms of business outcomes they're trying to achieve or political outcomes they're trying to achieve. And people also think in terms of the actions they have available. Traditional machine learning and artificial intelligence isn't usually presented in terms of actions and outcomes. And this is what decision intelligence adds to these important fields. To give you an idea of what we mean by actions to outcomes, this is a very simple decision diagram with some fancy graphics in the back. The decision is on the left-hand side. You can see I'm moving bars up and down, representing my decision to give money to a charity. This charity says that it will plant trees. Those trees will then grow to create some amount of biomass. That biomass sequesters carbon. That sequestered carbon, I hope, if I make this decision and millions of people make the same decision worldwide, that will help to reverse the negative effects of climate change. So the outcome that I care about is the climate change on the right-hand side. The action I can take is giving money to a charity on the left-hand side. And in this simulation, if I make good decisions, I see these trees growing. If I make bad decisions, we see fire and we see much fewer trees. Now, this is just one visualization of a decision model. There are many different ways that we might visualize this action to outcome pathway. Oops, I pushed the wrong button. Let's see. So here's another representation. This is more of a simulation that might be used by a commercial company. Again, we have some choices on the left-hand side. This company is producing some widget. Maybe it's making T-shirts, and it's trying to decide how much it's going to charge for every, or how many T-shirts it's going to produce. And then it also has some carbon tax. It has some emissions coming out of its manufacturing plant. And because there's a lot of smoke coming out of its manufacturing plants, its government has imposed a tax. And so now it's faced with some decisions, which are represented in the yellow. I'm deciding how much of the old plant versus the new plant that I should buy. And I'm also making assumptions about the interest rate that the bank will charge me if I finance the new plant. Now, the idea of this new plant is that it will be cleaner, is that it won't produce as much carbon emissions. And because of that, I will have a lower carbon tax. And I'll also have people who care about my company being green liking me more, which is this thing at the very top, and they'll pay a higher price. So you can see there's this very complex dynamic between the choices I make in yellow and the two outcomes on the right-hand side. One is my revenues and the other is my carbon tax. And I'm trying to keep my carbon emissions, and I'm trying to keep my carbon emissions low. I'm not going to go into the full details of this. There are some videos online that describe this model. If nothing else, please remember, we have actions on the left, we have outcomes on the right, and then there's some complex system dynamics, some complex feedback loops that are going on between my actions and my outcomes. This is common to decision intelligence as a whole because it unifies system dynamics, specifically complex system dynamics, with AI and with big data. And this is necessary to solve some of the big problems that we face, as we'll talk about a little bit later. So let's take a deeper dive into decision intelligence. I'm going to talk about a diagram that you can draw today. You can go home and do this now. You don't need technology. You can draw it on the wall. You can tell it to your kids. So without technology, you can still use a causal decision diagram to capture your decisions. This one is very complex. I'm not asking you to understand all of the parts, but I do want to point out, again, on the left-hand side, we have some actions that we could take. In this example, those actions are choices made by someone who manages an office building during a pandemic. And their choices have to do with when can people come back to work? How much money should I spend changing my building so that it's safer with COVID happening? Should I invest in my heating, ventilation, or air conditioning, HVAC? How much should I invest to convince people to keep socially distanced, complying with masks, and then maybe some signs in the building to try to convince people that safety is important? So we have many decisions, again, actions I can take on the left-hand side, outcomes on the right-hand side. I want people not to get sick. I don't want them to die, but I need to keep my business profitable. In the middle is some fairly complex dynamics having to do with how your heating systems work and how people move through the building and how the COVID particles move and how that impacts whether people will get sick or not. One other piece of a causal decision diagram is something called externals. Those are in the lower left of this diagram. These are things we can't change. The building shape, the infection rate in my prefecture, the demographics, how many old people come into the building, how many young people, behavior of the virus, and then any government constraints. I can't change any of these things, but depending on the shape of my building, that will combine with the choices that I can make to lead to outcomes. Those of you who do artificial intelligence might recognize this as sort of a causal diagram. And causal modeling is a very active area of artificial intelligence research that is helping to inform decision intelligence. Essentially, we're modeling how the world works in a diagram. So my challenge to you, go home, talk to a family member tonight, ask them what outcome they're trying to achieve, ask them what actions they're taking, and start writing those down. So often for complex decisions, we don't draw a diagram. Drawing a picture that connects actions to outcomes is very, very powerful. It's like having a blueprint for the first time if we're building buildings. It's like having a computer-assisted design system to build an airplane. Without a diagram to capture the complex decisions, the complex dynamics within decisions, it's much harder to agree to decisions and to make them right. Here's another example, a much simpler one this time, of a different causal decision diagram. As you can see again, there are decision levers or choices or actions on the left-hand side. Oops, I pushed a button I didn't mean to. Let's go back there. And there's outcomes on the right-hand side. This is a very oversimplified security situation where, let's say that I'm watching my computer systems and I have a machine learning model that says there's an intrusion happening. I have another machine learning model that gives me the type of the intrusion, whether it's a DDoS attack or some other kind of intrusion. What this model does is it says those machine learning models are very valuable, but they don't go so far as to tell me what to do about it. I have a prediction of an intrusion. I have the type of intrusion, but a decision model adds to those two predictions actions that I can take and outcomes that those outcomes might realize. So this is very simple, but maybe I have a choice as to whether to call the police or to investigate an intrusion inside my company. Those choices combine with various factors to determine the outcomes I care about, which is I don't want to lose business from intrusions, I don't want to lose reputation from intrusions, and I don't want the intrusions to cost society a lot of money. So I have multiple outcomes that I'm trading off, multiple actions I can take. The causal decision diagram is a way of drawing a picture of how these combine together. One more point, which is the how and the why. So why, the reason I'm sending intrusion information to the police can be explained by going from the left to the right in this diagram. The how goes from the right to the left in the diagram. How am I going to reduce the loss of my reputation due to intrusions? By realizing that the police might have a benefit by sending intrusion information to the police. So again, if you ask your family member about their decision, if you ask them why, they will tell you how their actions lead to their outcomes in their head, in their imagination, how actions lead to outcomes. Here's another very simple causal decision diagram. We're going from the most complex to the most simple to see if you can understand this. Again, we have actions on the left. In this case, they're called levers, but that's pretty much the same thing. Outcomes on the right. And the purpose of this diagram is to show you that a decision model, a causal decision diagram, is different than a process diagram. Let's imagine I'm going to drive to the store, the grocery store. I'm going to reach up and select which coffee I'm going to buy for my coffee cup here. There it is. I'm going to go and pay for the coffee, and then I'll drive back home. Those steps are a series of tasks that we might capture in a project management tool like Microsoft Project, in a Gantt chart, in a process flow. Each one of those steps, I have a choice. I'm driving to the store, I'm selecting the coffee, I'm paying. This is different than a causal decision diagram. In a causal decision diagram, this one is modeling just the selection of the coffee. After I choose to buy a particular coffee, that sets in motion a series of events that are not under my control. If I care about the environment and I care about the coffee workers, maybe I have read that there's some abuse of people who are farming coffee. And I know that if I buy the fair trade coffee, that will create a better economy for those workers. And I care about that. Then I might make the choice to spend more money by selecting the fair trade coffee off of the shelf. After I've made that selection, the impact on the economy and on the workers and on the environment is no longer in my hands. And this kind of a situation is very common. If I'm a legislator and I'm creating a law, how that law is used and implemented is not in my hands. And so I need to model things that are outside of my control, not a process diagram. If I'm in a company as a senior manager and I'm setting a policy, perhaps who can fly on an airplane this year, what's my travel policy? I'm not controlling the process by which people book their flights and then get on the airplane. Instead, I'm setting a policy that will have an impact throughout my organization that's outside of my control. This is the essence of a causal decision diagram. We're modeling things that once we take an action, they have a ripple effect, we might call it a domino effect, to reach some kind of an outcome, and that outcome is no longer under my control. Typically, when we have a workflow or we have a process model, drive to the store, select the coffee, pay for coffee, drive back home, each one of these steps includes a decision. As I drive to the store, am I going to drive my Toyota car or my Honda car? That's a choice that I'm making that has an impact on the environment, on my safety, and more. So typically we do have decisions inside these process steps, but the decisions are different than the process steps. This is a difficult distinction that when I teach my course, It's hard for people to understand. So we will come back to another causal decision diagram in a moment to understand this again. Moving on, let's talk about how decision intelligence connects to artificial intelligence and machine learning. As technologists, of course, you know, we've had an explosion of data, and AI and machine learning are really changing how we live today and have had a big impact on society. In general, there's a big difference between the decisions that we make with AI and the decisions we make with DI, or decision intelligence. Decision intelligence is about action to outcome decisions. It's about a decision for me to choose the coffee, or me to create the policy, or for my company to acquire another company, or to include a new feature, or to call the police in a security situation. Each one of these are actions that I take that benefit from a digital twin of the situation simulated inside a computer to help me decide what will be the outcome of me choosing to select this coffee or create this law. This is very different than AI and machine learning decisions. AI and machine learning decisions usually fall into two categories. One is a classification decision. I'm looking at a picture. I'm deciding that this is a picture of a cat or a dog. I'm looking at a particular stock. I can decide, is this security something that I want to invest in because it will go up or it will go down? The other kind of decision we see within AI and machine learning is a regression decision, where we determine some kind of a number or a score. Here's a customer. I think they're very likely to leave my company. This is a churn score, which is a very highly successful application of machine learning inside companies. As you can see, the classification task, the decision that something is in a category, and the regression task, the assigning of a number to something, is very different than a decision to take an action in the world, which will lead to some outcome. It's strange. We have the word decision, which really means two very different things. I've decided that this is a picture of Kaneko-san on my screen, but that's a very different decision to the decision for me to, oh, there you are, the decision for me to speak to you today. I'm taking an action decision to lead to some outcome. So really very, very different kinds of decision. And Kaneko-san, you talked about the decision modeling notation earlier, which is very important and an important way of capturing decisions. That applies to these classification and regression decisions, not to the action to outcome decisions, which needs a causal decision diagram. So stepping back for a moment, decision intelligence is about bridging the gap between how technology works and how decision makers think. Again, decision makers think in terms of actions they can take that lead to a business outcome. I want my company to be profitable, or a government outcome. I want people in my prefecture to be safe from COVID. It is not usually how decision makers think, non-technologists think, to just do a classification, just do a prediction. People want the technology stack, the software, the hardware, analytics, and AI to be modified into this action to outcome picture. My dog, who you heard barking over here, he thinks in terms of actions and outcomes. My dog knows if he's in a particular context, he's in the kitchen over here, and I say sit, he sits, and then the outcome is I give him a cookie. I have his cookies here right now, actually. So he gets a cookie, right? So not just humans, But dogs and many animals follow this ABC concept: antecedent, your context; behavior, B for behavior, which is your action; and C, the consequence, the outcome. So this is a very widespread model within psychology of how people think and how dogs think. It is in many ways the most natural way to think. And yet, until now, data and artificial intelligence are not fit within this action to outcome framework. Furthermore, decision intelligence helps us say, okay, we have one outcome for the decision maker, which outcomes that impacts their team, which impacts their stakeholders, which impacts the world, right? So in decision intelligence, we have these chains of cause and effect. And we recognize that your action doesn't just have a near-term effect, but it often has a longer-term effect on the world at large. And so this is where we start to get into using decision intelligence to solve some of the great problems that we have. So if we come back to the CDD, I hope this is maybe a little more clear. Again, we have these actions and outcomes, and those triangles are machine learning models. So it's still useful to have a model that does classification, what's the type of intrusion, or regression, what's the score of the intrusion? Is it a high score? Do we think we're very confident that someone's intruding into our computer systems right now? Those are still very useful, but they are only part of the picture. Decision intelligence puts the rest of this diagram around it and then gives us technology that lets us run a digital twin of the situation so that we can make people sick from COVID in simulation instead of in reality. And then here's how we change the COVID diagram to include technology as well. So this is the same complex diagram I showed you before, with actions on the left and outcomes on the right, but I've added something. I've added where technology can help us. So there are machine learning models, those triangles, but we might also have a computational fluid dynamics simulation, which says, if I'm breathing out COVID particles, here's where the particles float in the room, depending on where the air conditioning is moving the air. Very, very important, because what we find is that there's pockets where there's a lot of particles and other pockets where I'm safe. And so we have a machine learning model. We have a computational fluid dynamics model. We can also have behavioral psychology models or behavioral economics, which is very, very important, but is often overlooked. How we influence people's behavior is an important part of many decisions, and yet we tend to leave these separate. The marketing department, that's in charge of people's behavior. The engineering department is separate, and we're not so good at integrating those together. So what you can see here is that we have actions and outcomes. We have a diagram, and then we can add the simulation. And this diagram is valuable by itself, even if we don't build a computer simulation. But it's very valuable if we use this as a specification for a computer simulation that shows how to orchestrate and combine machine learning models as well as other models together with IoT, as well as other kinds of technology. So I will say, since you guys are an IoT group, these eyeballs in the lower left, that's where we might use a sensor to detect what's going on within my building. And that behavior of the virus particles or the air movement combines with my decisions in order to determine if people get sick or not. So this is a way of integrating multiple technologies into a model on paper and also in simulation that help people make better decisions. Very, very exciting. And there's a picture of my simulated COVID particles that I built with actions on the left and outcomes on the right, and people walking around inside the building. So this is very different than what happens today. Returning to the COVID example, I know when I'm trying to decide, should I wear a mask or should I go to the grocery store? I'm given data and models and predictions. What I really need to know is if I go to the grocery store, what will be the result? Will I get sick from COVID? Do I need to wear a mask? What are the impacts of my decisions? So this is very different. Again, decision intelligence builds on AI and machine learning. We've had a revolution in machine learning because it allows us to build software without writing code, which is amazing. We just give examples of cat, 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 dog, 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 give this to our machine learning system. And without writing software, by seeing only examples, the machine learning system can build software automatically. This is amazing, and it has changed many, many industries. But machine learning is limited. It's limited to situations where we know the truth. So we train the computer, we say, that's a cat, that's a cat, that's a cat, that's a dog. And usually, often in complex decisions, we don't have historical truth. It's limited to classification or prediction. It also is usually used in only single link situations, not when we have an action that leads to something, that leads to something else, that leads to something else, that leads to some outcome, multi-link actions. Also, machine learning typically requires very specialized expertise. In contrast, decision intelligence addresses these limitations of machine learning. It's used for humans to work hand in hand with the computer, not to have the computer fully automate the decision, but to act as an advisory to people, to run a digital twin so that we can observe the impacts of our choices on our actions. It allows multi-link connections and also gives us a way of doing machine learning orchestration and what we call machine learning ops. This is a slide that shows the result of a recent project I've done working with farmers who are growing sweet potatoes. I should have gotten one so you could see it. Sweet potato in this country is a little potato and it's orange. And these farmers are trying to decide what to do if they have a parasite in their field. So they test the soil and they see this little worm, and they know that worm is going to hurt their crop. And so they have some choices. Should they maybe not even plant sweet potatoes, or should they apply some substance on the ground that will kill the worms? We drew one of these causal decision diagrams with sweet potato experts, and then we said, where is the research that will help us to give us technology so that we can run a simulation? And what we learned was a big surprise. Most of the research focuses on only a small part of the decision, on soil temperature and soil moisture. Many of these linkages here have no research. And so this was a big surprise to us. When we structure and draw a picture of the decision made by farmers, and then we say, where is their data to help us? We can learn where the data is available, and we can also use this to guide priorities for future research. Without a decision model like this, in many fields, not just in farming, the data people are often guessing. They don't know for sure at the use that decision makers will make of their IoT, of their data, of their machine learning systems. So what we need to do is to step back from the data, work with experts to draw a picture of actions and outcomes, and use that to help to prioritize data gathering, IoT, machine learning, and other technologies. In this way, drawing a causal decision diagram is a requirements methodology for supporting people who need to think about some set of action choices and how those actions might lead to the outcomes that they desire. And this research is ongoing right now. So the last topic I'd like to talk about is how decision intelligence has the potential to solve some of our hardest problems. If we look at income and wealth inequality, conflict and war, COVID-19 and other pandemics, climate, and many complex business problems, at first you might think these are very different, but it turns out they have some characteristics in common. They're very similar. They have invisible effects. We can't see the COVID particles. We can't see when I choose to buy this coffee, what it does to the climate. So that it has invisible effects. They are effects that play out over long chains of time and space. My choice to buy coffee will only have an impact on the environment 10,000 miles away on the coffee plantation and maybe 2 years from now. And it will be a very small impact. But if I make a good decision and billions of other humans make good decisions, then that small impact will be very large. So invisible, multi-link, and then the last characteristic that's common to many of these challenging wicked problems is that they involve feedback loops, emergent properties, and that they're exponential. So we need complex systems understanding in order to really understand how my choice, my decision, leads to some outcome over time. We can't do it on our own. We need a computer simulation. And computer simulation isn't new. It's what the Apollo 13 astronauts used to get back from the moon. It's what pilots use. I wouldn't fly in an airplane when the pilot hadn't been trained in a flight simulator and had been challenged with many unusual situations. Decision intelligence brings the power of simulation to a much wider class of problems. Much like digital twins. In fact, there's a big overlap between decision intelligence and digital twins. It allows us to use computer power to kill people in a computer in simulation or make people sick in simulation instead of doing so in reality. So here's kind of a summary slide of what's going on here. There's an explosion of different kinds of technology over the last 2,000 years, from analytics to statistics, simulation, artificial intelligence. All of these technologies have been quite separate, not integrated together to solve the hardest problems. So what we're doing in decision intelligence is working together to crystallize these separate technologies into an integrated picture, which meets us at the point of a decision maker. No matter how complex things are, we are all just an individual human or an individual organization with some choices that we can make and some outcomes that we should achieve. So decisions are the unifying principle that we really think will lead to a solutions renaissance, a reintegration of multiple technologies that we haven't known how to connect together to solve the hardest problems. So today we're on a journey. Decision intelligence is only about 12 years old as a field. It is brand new. You've probably never heard about it before today, but I invite you to join this very exciting field whose job it is to solve the hardest problems. This is a very busy slide, so I'm not going to read everything here, but I do want to say that when we start to draw diagrams of something complex, that creates an explosion of possibilities. How could we build a tall building without a blueprint? How could we build an airplane without a computer-assisted design system? How can we solve the hardest, most difficult decisions that we face without drawing a picture of it, without using engineering, without design, quality assurance, collaboration to create those diagrams. When we do that, it helps humans align better, number one. It helps us solve these wicked problems, these very difficult societal problems better, as I talked about previously. It is an integration between humans of different disciplines, but it's also an integration between humans and technology. It's a way of understanding how the technology supports what's most natural to me and my dog, which is to take an action in some context. It extends machine learning. And when I talk to my friends who are just directors of analytics or chief technology officers, they tell me that they've made a big investment in a database and a decision support system and in a business intelligence system, but those aren't getting used for the most important decisions. They tell me that decision intelligence is the last mile, the last connecting link in the chain that's needed to make the most value out of these existing investments. It's a way for organizations to do more data-driven and evidence-based decisions. And something I haven't talked about much is the ethical side of decision intelligence. It is available. It makes the technology not hidden, not just something that Google can do or big organizations can do, but just like my personal computer here brought technology to my desktop, decision intelligence is bringing analytics to more people, not just to the experts. And then it's also transparent, diverse, and allows for social responsibility. So decision intelligence is so important, and I'm so grateful to have had the chance to speak to you today. Thank you very much for this opportunity. If you'd like to learn more, my book that's already published can be found at linkthebook.com. The new book, the Decision Intelligence Handbook, you can sign up to be notified on early release. It's at dihandbook.com. And then you can also see my other contact information here. Again, I welcome you guys on an amazing journey. I hope that 20 or 30 years from now, you will look back and you will remember this moment as the time you learned about decision intelligence, which is critical for bridging our most powerful technologies to solve our most challenging problems in the commercial world, as well as for human society at large. Domo arigato, Kaneko-san.